Ayan. So, okay. So, let's continue the other half ng topic na to, which is on addition reactions pa rin sa alkene. So, okay, before we continue, let's have some review muna, no? So, ano yung ganap natin sa alkene? So, alkene is a product, no? Isa siya sa product ng um, elimination ng alkyl halides, 'di ba? So, yung double bond na yon ng alkene, yun ay electron rich and it can serve as your ano, yun ay pwede maging nucleophile, no? So your double bond can serve as nucleophile or it could also serve as your Lewis base, no? So yung bonds nun, yung electron dun sa bond na yon, yun yung gagamitin niya to create bond with other atoms, no? So it can be either a Lewis base, oops. So it could either be a Lewis base or pwede rin namang electrophile, no? Same concept lang, no? Kung saan yung electrons sa double bond ang gagamitin to create bonds, no? However, dalawa lang yung electrons dyan. So kapag kumabit yung isang atom dyan, magkakaroon tayo ng carbo-cation. And what do we know about carbo-cation, no? So the position at which your carbo-cation is located, it could tell you kung stable ba siya or not, no? So usually our carbocation undergoes rearrangement, no? In order for it to be stabilized, no? Ano yung reason kung ba't siya nagre-rearrange? Hyperconjugation, no? Or the stability, no? So the more atoms you have here around it, no? The more electrons will pass through that empty p orbital, so it will be more stable. Okay, depending on the condition of your experiment, no, of your setup, you can either have an addition reaction or elimination reaction. Pwede ito pumunta ng addition, na setup pwede maging elimination reaction. So yan, so depende sa conditions, depende sa temperature, depende sa chemicals, yung ating maging reaction, no. So for example, ang ating So, ang ating reaction, pwede yung double bond, maging addition reaction siya at low temperature. However, at higher temperature, hindi ganito yung mangyari. Hindi addition reaction yung mangyari. Rather, magkakaroon tayo ng elimination, no? Okay, bakit lower temperature yung yung favored ang addition reaction? Kasi the delta S here is negative, no? Kasi two molecules to, pagdating dito, isa na lang sila. So we want that negative delta S na value na maliit, ma-minimize yung entropy factor. Gusto natin mag-dominate si enthalpy. That's why addition reactions are only possible at low temperatures. No? Bakit low temperature? To minimize the entropy term para mababa yung value niya. So hindi niya ma-overpower yung delta H, no? Okay? So, however, at higher temperature, ano mangyayari? Magiging baliktad yung reaction natin, no? So, mas favored ang entropy at higher temperature, no? According to the Gibbs free energy equation. So, it will undergo an elimination reaction, no? So, inalam natin last time yung ilan sa mga reactions ng ating alkenes such as hydrohalogenation, acid catalyzed hydration, oxymercuration demercuration, and hydroboration oxidation, pati catalytic oxidation. So, 5 pala yung na-discuss natin, no? Ngayon, onti na lang yung natira sa atin actually. So, ano meron sa hydrohalogenation? So, what you have here is your alkyl hindi alkyl. Ano tawag doon? Acid halide. No? So, ano yung acid halide? HX lang yon. So, pwede yung hydrochloric acid, hydrobromic acid, hydroiodic acid. No? So, itong mga acids na to, this can be added sa ating double bonds. No? So, what will happen is that your double bond will attack your acid halide. Okay, so ipupull niya yung hydrogen. As it pulls the hydrogen, ibabalik ni hydrogen yung bond kay bromine, kay halide, no? So that will give you a cation. So that cation can rearrange. No? Kunwari, dito napunta yung H, tapos nandito yung cation, that cation will rearrange. No? Bakit? Stability. No? So yun lang yung reason. So magre-rearrange siya into a more substituted carbon. Then finally, your halide, your nucleophile, will attack that carbocation. What else do we know about this? No? Ang isa pang alam natin dito is that the carbocation is sp2 hybridized. No? sp2 hybridized yan. So, ano mangyayari? Your nucleophile can attack either the top part or the bottom part of that sp2 hybridized plane. No? Itong trigonal planar na yan. So, if the carbon, kung nasaan yung carbocation mo, if that carbocation is a stereocenter, ibig sabihin it has 4 different groups around it, then we could either have a racemic mixture of R and S, R and S compounds, no? So yan, dalawa yung magiging products natin, R or S, and that is only if yung ating carbocation ay siya ay stereocenter or may 4 different groups around it. No? Just check the molecule, no? Kung ano yung mga nasa tabi niya. Pag magkakaiba yung nasa tabi niya, stereocenter yan. So may RNS ka doon. However, if that carbon is not a stereocenter, so wala kang RNS doon. Okay? So yun lang. Yun yung sa hydrohalogenation. What else? Acid catalyzed hydration. So what we know about acid catalyzed hydration is that instead of X yung kakabit, instead of the halide, ang kakabit ay OH from the water. Okay? So what we have here is a protonated water or protonated solvent such as H3O+. Water lang yan na may added proton. Okay? So that speeds up the hydration of your double bond. No? Meaning ng hydration, yung OH kakabit sa double bond. What will happen here is that your double bond will attack the hydrogen. Okay, so you will have a carbocation. Then your water will serve as a Lewis base or a nucleophile. The electron of the oxygen will bond to that carbocation. So pag nag-bond yung ano nangyari sa mouse? Ayan. So itong lone pair, kapag umatake yan sa carbocation, yan, magkakaroon ka ng tinatawag nating oxonium ion. Then finally, in order to regain our catalyst, yung H3O+, no, or yung protonated solvent, the water molecule, another water molecule, will abstract the excess hydrogen sa ating oxonium ion, yung hydrogen bonded with oxygen. So, hihilahin niya yung isang hydrogen doon. So, magiging OH na lang yan. Okay? So, depending on the conditions of your experiment, you can either have an addition reaction or elimination reaction. So, if our concentrations are dilute, teka lang, check ko lang yun nasa labas. Kala ko kung ano. Okay. Nasa na ako? Ayun na. So, depending on your experimental setup, your conditions, your reaction may undergo an addition reaction or it could also undergo elimination reaction. No? If your acid is weak, mahina lang yung acid mo, dilute lang siya, so onti lang yung proton, maraming water, then it is possible na mangyari yung addition reaction. However, if you use concentrated acid such as concentrated sulfuric acid, ano mangyayari? Itong OH na to, mababaklas yan talaga. No? So, since onti lang yung water, hihilahin ng acid itong OH to make more water. As a result, magiging ganito yung ating molecule. Mag-undergo siya ng elimination reaction. Okay? Similarly, with our hydrohalogenation, yung hydration natin can have stereochemistry stuff then, no? Pwede ka rin mag-form ng RNS molecules, no? Because again, may carbocation tayo dito. Okay. The next type of reaction we discussed last time is the Oxymercuration Demercuration. So this is a two-step process, two-step reaction of your alkene to form a hydrated alkane or may OH lang, no? So ano yung difference niya with uh, acid catalyzed hydration? So, ang difference is two-step siya, okay? And then, yung ating carbocation, it will not undergo rearrangement. And our product is always the Markovnikov addition. When you say Markovnikov addition, yan ay yung iyong OH, yung iyong halide, whatever your nucleophile is, kakabit siya sa most substituted ano, sa most substitute tawag doon, carbocation. Maingay sa paligid, hindi ako makafocus. Okay. So, anong nangyayari dito? So, the first step is that you have your oxymercuration process, no? In which you will have your mercuric acetate, no? So, mababaklas yung isang acetate molecule yan. You will have your mercuric cation that will bond, no? I mean, hindi bond. That will bind pala, no? Kakabit siya sa iyong double bond, no? So basically, gagawa siya ng tinatawag kong clip. Nakasipit siya doon sa dalawang carbon kung nasaan nandun yung double bond. So ang purpose niyan is para hindi mag-rearrange yung carbocation. Either dyan siya or doon siya. Okay? So iipitin niya yung carbons kung nasan mapupunta yung carbocation to prevent yung ating rearrangements. No? Then finally, your nucleophile will attack the most substituted carbon, releasing this bond. Itong clip, mapuputol na yung clip na yan. So, ando na yung nucleophile mo. So, that's the first step of the oxymercuration. Your double bond, kakabitan yun ng mercuric acetate. No? Tapos, yung nucleophile kakabit sa most substituted carbon. So, magiging isang bundle lang yun sa HGOAC. Then finally, yung demercuration. Okay? So itong demercuration, ang ginagawa lang dyan is you will react this molecule with sodium borohydride, NaBH4. Ang purpose lang is para yung hydrogen ang pumalit dito. Okay? I don't know if naka-experience na ako na doon sa lab, pero alam ko nagiging solid yung mercury doon eh. Kasi namumuo sila sa ilalim. Okay? So, yun lang yung oxymercuration, demercuration process. Okay? So, again, the difference is that compared to acid catalyzed hydration, dito may rearrangement. However, for oxymercuration, demercuration, no rearrangements will happen. Okay? Ito, next reaction na pala. Ang taka ko, parang parehas lang, hindi pala. Okay, so the next type of reaction na na-discuss natin last time, nagtaka pa talaga ako, hindi ko binabasa yung title eh. Okay, so the next type of reaction is the Hydroboration Oxidation. This works similarly as your oxymercuration demercuration. No? However, the product here is anti-Markovnikov compared to the Markovnikov product in your oxymercuration demercuration. So, sa oxymercuration demercuration, your mercuric acetate will clip sa iyong double bond. This time naman, sa hydroboration oxidation, your borane, si BH3, si Be, yan ay kakabit sa double bond. No? Similar lang yung ginagawa nila. Saan ba yan? Yan. Ayan, so ayan. So itong BH3 mo, siya ay kakabit sa double bond. However, ang magiging deciding factor kung bakit siya naging anti-Markovnikov, bakit yung iyong nucleophile ay kakabit sa least substituted carbon is that ganito. Yung BH3 mo, magpo-form yan ng clamp dito sa iyong position ng double bond. However, due to steric factors, yung BH2 ng BH3 ay mapupunta sa least crowded position. So, hindi siya mapupunta dito. doon siya mapupunta. So as a result, yung hydrogen yung kakabit dito, no, sa most substituted carbon, hence anti-Markovnikov nga siya. Then itong BH2 na yan, that can be attacked by a nucleophile, no? So pwede na kumabit dyan yung nucleophile, so mawawala na siya. Ayun. So yun lang. And hydroboration is also stereospecific. Now, when you say stereospecific, may certain arrangement siya in 3D space. No? Kasi as you can see, yung clamping ng ating BH3 ay same side, no? Parang isipin mo yung sipit na sa same side yan, di ba? So, ibig sabihin, when we are doing hydroboration, oxidation reaction, nasa same side parate yung dinadagdag nating atoms such as the hydrogen and the oxygen. Okay? So, same side sila. So, tawag doon ay syn addition. Okay? So, yun lang. So, syn addition. So, kung yung H mo nasa taas, yung OH mo nasa taas din. Pag yung H nasa baba din yung OH. However, this can only be applied if your carbon is a stereocenter. Pag hindi yan stereocenter, it doesn't matter. Okay? So, yun lang. Then last time we discussed the catalytic hydrogenation. No? So ano nang nangyari doon? Your double bonds ay ginagawang alkane. No? So from alkene to alkane. So this is also syn addition. Same side yung addition niya. Because imagine your double bonds, your hydrogens added to the double bond in this manner. Ito yung iyong catalyst, usually platinum, palladium, or nickel. So dito yung hydrogen sa surface niya. When your double bond attaches to this side of the catalyst, no, ibig sabihin nun, yung hydrogens mo madadagdag on the same side. No? Parang clip din yan. No? Sipin nyo yan yung dalawang lollipop na na kakabitan ng, kunwari, ito alkene mo. Dalawang lollipop, ganun mo. So yung lollipops, dadidikit sa same side ng alkene mo. So, ganun lang yung idea. Okay? So, yan. So, syn addition din dito. Okay? So, as a result, no, sometimes we form meso compounds here. So, what are meso compounds? Again, those are molecules which have a plane of symmetry. No? So, may plane of symmetry lang dyan. No? So, yan. So, ang number ng stereocenters dyan ay way less than the usual enantiomeric ones, no? So, yan lang. Ano pa meron dito? Ayan, so dalawa yung processes ng ating hydration, no? We can either have your hydrogen dissolved in catalyst na metal, or you can also use a ligand, no? So, ano yung ligand? Yan ay molecule na malaki, no? Such as this one, the Wilkinson's catalyst. So, mapapansin nyo, itong Wilkinson catalyst, para rin yung clip, no? Yung pH3, no? Yung na yan. Parang clip yan nakakabit din sa double bond, no? So, parang sipit itong side na to. Ito yung kakabit sa double bond. So, you will have your syn addition, no? So, dalawang options mo. Pwedeng catalyst na metal or Wilkinson's catalyst. Okay? Ito naman, asymmetric hydrogenation. Hindi naman to dinidiscuss masyado. Pero, medyo important siya sa science kasi bihira gawin to. No? Ayan, so may nanalo pa ng Nobel Prize dahil dyan. Okay? Next one. No? Proceed na tayo with the next lesson na. Okay? So, ayan. So anyway, so let's proceed with the next reaction of your alkene, which is the catalytic hydrogenation. Okay, so ano meron sa catalytic hydrogenation? Catalytic hydrogenation. Ibang slide yan nababasa ko. I mean, halogenation. Ano meron dito sa halogenation natin? Basically, your double bond will have halogens, no? So, anong mangyayari dito? Yung halogens mo kakabit sa double bonds lang. Okay? So, this is one step in making plastics such as polyvinyl carbonate, no? Or PVC. or polyvinyl chloride, PVC din yun, no? So, yun. Yun yung ating mga reactions dyan. Pakita natin yung steps, no? Meron ba dito? Wala pa. Okay, so anyway, hindi pala pinakita yung steps. Okay, so anyway, so yan yung ating halogenation. You have your halogen, molecular halogen. Ano meaning ng molecular halogen? Dalawa yung atoms ng halogen sa isang molecule. Okay? So you have your molecular halogen there, then kakabit siya sa double bonds, no? Okay? So this is only practical, meaning ito ay possible only with Cl2 and bromine, no? For iodine, hindi siya makikita. For fluorine, that is too violent, no? Nagwawala. Bakit, no? Kasi yung fluorine, medyo OA yan talaga mag-react, no? Because of its electronegativity. Hihilahin niya yung pwede niyang hilahin, no? So that's too reactive, no? Pwedeng sumabog yung setup, no? So yun. So that's why we only use this for Cl2 and Br2 as always. Okay, so how about the regioselectivity? When we add bromine, it happens, no? The halogenation process happens via anti-addition process. Di ba kanina alam natin yun? Syn. Kapag syn, parehas silang nasa taas, parehas silang nasa baba. Pero for halogenation, ang nangyayari ay anti-addition. So mamaya discuss natin yung discuss natin kung paano naging anti yan, no? Yung anti meaning nun yung isa nasa taas, yung isa nasa baba, okay? So yan. So ano ba meron dito sa ating halogens? Bakit siya nag-undergo ng reactions with alkene? So basically, your halogens are polarizable. Ano meaning ng polarizable? 'Di ba maraming electron mga 'yan, no? So those electrons, no, they can be easily affected by disturbances in the electric field, no? So for example, you have your double bond here. We know that double bonds have electrons. Kapag dumikit yan sa iyong halogen, ano mangyayari? The electrons of your halogen will be polarized. Meaning ng polarized ay matutulak papunta sa gilid, no? So when that happens, yung electron na pupush papunta sa isang side ng molecule, magiging dipole itong molecule mo. Magiging temporary dipole yon. So since yan ay temporary dipole, that will give you a partial positive end and a partial negative end. So ito yung nucleophile mo, ito yung double bond. Pag dumikit yan dyan, ipupush ng electron ng double bond yung electron ng halogen papunta sa other side because of the repulsion. Okay? Then ano mangyari? May expose tong atom na to which will become partial positive. So that is the chance for the nucleophile to attack that atom. So yan, kakabit na siya doon. Tapos mangyayari na yung typical reaction natin. Okay? So yan. Ano to? Only anti-addition is observed, no? So syn addition does not occur. Bakit, no? So one factor is eto, pakita natin dito. Ano nangyayari kasi kapag yung ating halogen ay inatake ng double bond is this, no? So what we have here is this ito yung iyong halogen, aatakihin yan ng double bond. So ang magiging product niyan, so aalis itong isang halogen mo. Ang mangyayari diyan is magkakaroon ka ng bromonium ion or chlorinium ion, no? So ano yung itsura nun? Imagine nyo yung sipit ulit, no? Parang yung halogen mo yung sisipit naman doon sa double bond. However, yung iyong isang bromine, hindi yan pwede umatake sa same side kung nasaan yung bromonium ion. Bakit? Steric reasons, no? Steric hindrance, no? Masyadong crowded dito, so ayaw niya doon. Sa baba na lang siya dadaan. So as a result, what happens is that nagiging anti yung addition natin. Hindi siya syn addition, anti-addition. Ganun yung nangyayari, ha? So, ano uli nangyayari? Ulit-ulit din. So, you have your double bond. Sisipitin yan ng isang halogen mo. So, iipit siya dyan sa taas. You will have your bromonium ion, for example. Then, yung isa mo pang bromine, since hindi niya ma-access yung taas due to steric reasons, sa baba na lang siya aatake. Okay? So that's why you have your anti-addition. Okay? And then plus the enantiomer, no? So pwedeng ito nasa taas, ito nasa baba, or pwedeng ito nasa taas, ito naman nasa baba. So may enantiomers kanyan. Okay? So ganun lang. Stereoselectivity naman. No? So ano naman meron dito sa stereoselectivity natin? So yan, if you have a cis alkene, no? So kapag cis alkene, you have two isomers parati na mabubuo, no? However, if you have a trans alkene, you will have a meso compound minsan. Sometimes you can form a meso compound. Ano yung meso compound? May plane of symmetry, no? Okay, so yun lang. So may plane of symmetry yan. Kung titignan natin paano naging meso compound ito, remember, this is sp3 hybridized carbon and single bond lang yan. So that means the carbon can rotate, no? Pwede siya mag-rotate. Yung Newman configuration natin last time. So pwede mo iikot yung itong carbon atom na yan. So kapag ni-rotate mo yan, let's say by 180 degrees, you will have this. Ito yung may itsura niyan kapag flip mo yan doon. Di ba may plane of symmetry yan? Ito, yan. So yan yung plane of symmetry ng molecule na yan. So that means meso compound yan. So yan. So ganun lang. So kapag cis, usually meron kang enantiomers, RNS, no? Pero kapag trans, minsan may time na magkakaroon ka ng meso compound. And that is true only if the molecule is ano tawag doon? Hindi pala tama yung term ko na is. That is true if the molecule is, tama pala, symmetrical. Ayan, nakalimutan ko lang yung term na symmetrical. Okay, so yan na. So kapag cis, you have two enantiomers. Kapag trans, pag symmetrical yan, then you will have your meso compound. Let's try the following. No? Sakit ng lalamunan ko. Kate ng lalamunan ko lately. Anyway. Ayun. So let's have the following activities. No? So we have here A, B, C, D. So madali lang naman yan. Puro bromine, no? Ganun talaga. Okay. So pwede rin naman yan sa chlorine. Same concept lang. Okay? So kapag nakakain ng chlorine, ganun lang din yung gagawin nyo, ha? Okay. Huwag magugulat. Okay. So let's try this one. So letter A, we have here this molecule na may bromine. Pakita natin yung magiging reaction yan. Ang mangyayari, ipahiga ko yung molecule. So yung double bond, aatake yan sa iyong bromine. Tapos magkakaroon ka ng bromonium ion, di ba? So kunwari, yung Br ko, parehas nasa taas. Okay, so ganyan yung mangyayari, no? So pakita ko na alis yung Br ko. So I have this transition state. Although hindi nyo naman kailangan ipakita yung yung mismong steps, no? Pinapakita ko lang yung process dito. Okay, so you have your bromonium ion. Then ano mangyayari? Yung iyong Br minus, since hindi niya ma-access yung taas, ano gagawin natin? Sa baba na lang siya pwede lumusot, no? So takihan niya, pwede ito, pwede ito. So kapag dito siya umatake, nasa taas dito yung Br. Pag dito umatake yung Br natin, dito naman mapupunta sa baba yung Br. Andito siya sa taas na part na to. Pag ito ay umatake dito, mapupunta dito sa left yung Br. Pag yung Br umatake sa left, mapupunta sa right side yung Br. Okay? So, kunwari, atakehan ko siya dito sa left. So, what will happen is that, ganito. So, mapupunta ang iyong Br. Ang hirap mag-drawing ng 3D. Okay? So, nasa taas ang iyong Br. So, pakita ko yan, nasa taas. So, magiging dash, wedge dash yan. So, nasa taas ang iyong Br. Then, ano mangyari? Yung isa mong Br, dito siya umatake, diba? So, nasa baba siya. So, itong CH3 mapupunta yan sa taas. Okay? So, ganun lang yung mechanism niya. Yung Br2, gagawa siya ng bromonium ion. Then, itong triangle na yan, aatakihin niya ng isa pang Br. Okay? Either dito or doon. Kapag dito umatake, doon mapupunta yung Br sa taas na yon. Pag dito umatake yung Br, dito naman siya mapupunta sa taas na to. Okay? So, yan. So, to summarize, our products are the following, no? Kunwari, andito yung Br, andito yung CH3, andito yung Br, nakapataas yung CH3. Okay? Ang pangit ng drawing ko. Basta yan. Basta yan, makikita nyo, anti yung addition ng ating Br. Yung isa nasa taas, yung isa nasa baba. Okay? Let's have the next one. Next one, you have your alkene na iyan. So that's 2, and that's 3-methyl pentoene, no? So yan, react natin yan with Br. Ano ulit mangyayari? Bromonium ion. Okay? Pakita ko lang. Pero alam niyo na dapat kung ano itsura ng product, ha? Okay? Oopsie. So itong Br mo, yan, no? So saan pwede yan umatake? Either dito sa ilalim nito o nasa yung mouse. Ayan. Pwedeng nandyan, pwedeng nandun. Okay? Saan ko kaya siya pwede ilagay? Kahit saan. Kung gusto ko atakihin to sa ilalim. So, mapuputol yan. Okay? Then, ano mangyayari? Yung BR ko, mapupunta siya sa taas. Okay? Then, ano mangyayari dito sa BR? Nasa baba nito. Tapos yung CH3 mapupush pataas. Okay? So, ganun lang. Plus, of course, the enantiomer. Okay? Kapag ito nasa baba, ayun naman yung nasa taas. Okay? So, ganun lang. Let's have letter C. Ganun lang din. Hindi ko na gagawin yung reaction, ha? Okay. So, ito. Dito kakabit yung bromonium ion mo. Okay? So, dyan. If your Br attacks yung baba nito, okay? So, mapuputol itong bond na yan. So, mapupunta yung Br mo dito sa carbon na to sa harap, no? However, yung Br dito, nasa baba. Okay? Nasa baba. Pero, do we have to show na nakadash siya or naka-wedge? Is this carbon a stereo center? No. Bakit hindi? Kasi magkakaroon dito ng dalawang hydrogen, no? So, since may dalawang hydrogen dyan, so, hindi yan, stereo center. So, gaganyan lang yan, no? Straight line lang yan. Okay? So, ganun lang. Hindi mo na ipapakita to as, wedge or dash. Kasi this carbon is not a stereo center. May dalawang hydrogen dyan, eh. Okay? However, this one, ito ay stereo center. Bakit? May hydrogen, may Br, may group na to, and may group na ito. So, magkakaiba yung group na yan. Okay? So, ganun lang. Lastly, ayoko i-drawing yan. Ano ba to? 1, 2, 3, 4, 5, 6, 7. Heptanol, cycloheptanol. Ayoko i-drawing. Gaganito yung, direktahin ko na lang, Hindi ako magaling mag-drawing ng ganyan eh. So, nasa taas yung Br, nasa baba yung Br. Ganun lang. Okay? Plus, of course, the enantiomer, ha? Yung isang version naman niya. Ayan. So, easy lang, di ba? Ayan. The next one, halohydrines, no? So, ano nangyari naman sa halohydrines, no? So, this reaction happens when you have your halogen and water. Okay? So, may halogen ka and may water ka. So, what happens first is that yung iyong halogen will form the bromonium ion. Itong clip na to, yung triangle na yan. However, instead of the other halogen attacking that carbon, instead na yung isang Br yung kakabit, yung water yung kakabit, no? Hindi yung Br. So itong water, kakabit yan dyan. So you will have this oxonium ion uli, no? Then finally, yung remaining Br, so 'di ba may Br diyan? 'Di ba originally may Br diyan na pinalayas, no? Okay, so finally, para yan ay maging OH, hihilahin ng Br na yan, yung H na yan. Okay? So you will have your Br then OH naman, no? So instead of another bromine, OH ang kakabit. No? So ganun lang. Okay? So bakit kaya ganun? Bakit yung water yung kakabit instead of the bromine? Kasi sabi dito, mayroong competing interest. No? So may competing reactions because your water will outnumber the bromine ions if that is a halogen water. No? Okay, so yun. Minsan may tinatawag talagang bromine water. No? So may mga bromine water talaga. So yun ay bromine liquid na nasa tubig. No? So if ganun yung case, halohydrin yung formation. Halo meaning halide, hydrin, water, OH na. Okay, so ganun lang. As you can also notice, that is ano meron dyan. Yan ay naka anti-addition din, no? So yung isa nasa taas, yung isa nasa baba. Okay? So that is also true for chlorine. Okay, Br and chlorine lang naman yung ganon, no? So ito Cl2 then H2O, okay? So ibig sabihin yan ay magiging halohydrin kasi may water. Kapag wala yung water, anong reaction yan? Halogenation reaction lang yan, no? Pero since may water, halohydrin reaction. Okay, so ganun din. Same lang ng process, no? Yung isa nasa taas, yung isa nasa baba. So easy, di ba? Ano pa? So the selectivity, the regioselectivity of your halohydrin is this one. No? If your halide will add to the least substituted carbon. Bakit? Parang rin yung tawag doon, Hydroboration Oxidation. No? Kasi remember yung itong bromonium ion mo, crowded dito, di ba? Kunwari may substituent dyan, ayaw niya kumabit sa crowded kung sakali. Hindi siya kakabit sa crowded kasi masikip nga. So rather, it will choose the side na least substituted. No? So yung halide mo, mapupunta sa least substituted carbon because of the crowding. Isipin nyo na lang yung reason din kung bakit mayroong hydroboration oxidation. Okay? So yun lang. Then your OH, yung nucleophile mo, a-attack yan dito sa more substituted carbon. Di ba parang nga lang? Parang hydroboration oxidation lang. Ano pa to? Yun din naman yun eh. Okay, so yun lang. Let's try to do this. Predict the major products of the following reactions. Following reaction. So sa tingin nyo, saan kakabit yung Br? Sa least substituted carbon. So dun siya kakabit, no? So ang Br mo ay mapupunta dito. Teka lang. Draw ko muna. So yung Br nyo, dito kakabit. Then yung OH, dito kakabit na. Okay? So however, yan ay that is anti-addition. So ibig sabihin, kailangan natin ipakita yung kanyang anti-addition, pagiging anti-addition. No? So if yung Br ay nasa taas, if sa taas siya kakabit, so kung naka-wedge siya, ibig sabihin your OH ay naka-dash. That will push this methyl group upwards. Okay? So yan yung magiging final product natin. Plus the enantiomer as well. Ganun lang. Okay? Mapapansin nyo, ulit-ulit na lang yung ano, no? Ulit-ulit lang explanation nila. Okay? So, let's try this. So, yan, dami. Let's do this. No? Hindi lahat, no? Okay? So, onti na lang sagutan natin dito. Kasi, ulit-ulit lang naman eh. Siguro itong A and B, tapos itong dalawa sa baba. So, let's have this one. We have this alkene with bromine water. Bromine water, no? Ibig sabihin may H, tas may Br. OH at pati Br. For letter A, saan kakabit yung Br? Sa least substituted. So, dito mapupunta yung Br mo. Tapos yung OH mo, dito mapupunta. However, we should show yung pagiging stereo-selective niya, yung pagiging anti-addition niya. Is this carbon a stereocenter? Yes, no? Stereocenter yan. Kasi you have your hydrogen, your bromine, your methyl group, and whatever this is on the right side. No? So this is a stereocenter. So we have to show whether that's wedge or dashed. No? This carbon is also another stereocenter. Okay? So, magkakaroon dyan ng hydrogen, yung OH, then this group, and that group. Hindi. Wala palang hydrogen dyan. This group, this group, this group, and that OH. So, magkakaiba yan, na? Ito, CH2Br eh. Ito, CH2CH3. Ito, CH2CH2CH3. So, magkakaiba talaga yan, na? So, we have to show yung pagiging anti-addition niya, na? So, dudraw ko lang yung isa, ha? So, kunwari, nasa taas itong Br na to, kailangan nasa baba yung OH, no? Ito na lang i-push ko forward. Okay? So, pwede naman ito yung naka-push forward, no? Kahit ano naman, no? Basta tama lang yung position ng Br and OH mo. Okay? Pwede ito yung naka-wedge. Pwede rin ito, no? Plus the enantiomer. Ano yung enantiomer niyan? Ito yung naka-dash naman, ito yung naka-wedge, no? So, ganun lang. Let's try letter B. Saan kakabit yung Br? Sa least substituted. No? So, dito kakabit yung Br, yung OH doon kakabit. Then, what's next? Pakita natin yung pagiging stereo-selective niya. Suppose yung aking Br ay naka-forward siya kunwari. Naka-wedge. That makes my OH dashed, no? And that will push this methyl group forward, no? So the final drawing would be plus enantiomer. Okay? So ganun lang. Always check, no? Check nyo parati kung yung carbon ay stereocenter. Kaya ginagawa ko muna, ginaganyan ko muna, no? Nile-layout ko muna yung itsura. Then saka ko na nilalagay yung tawag dyan, yung pagiging wedge and dash niya. Okay? So ganun lang. So let's try ito naman. 2.2. Hala, sir, paano yan? Hindi siya water. Hindi yan water. Ano yung solvent natin? Yan ay ethanol. No? So, okay lang naman. No? So, the concept, kapag iba yung solvent, no, same lang din. No? So, same lang yan, whether that's water or other solvents. No? Okay? So, ganun na. Same process lang gagawin natin. Yung Br kakabit sa least substituted, yung solvent mo kakabit sa most substituted. However, ano yung mangyayari? Itong ating solvent, mababawasan siya ng isang hydrogen parate, no? Tignan niyo yung nangyayari sa water. Yung H2O, ano nangyayari? Nagiging OH na lang siya. Okay? So, ganun din gagawin natin sa ibang solvent. Babawasan lang natin ng isang hydrogen. So, basically, ang matitira, ang kakabit ay ito lang, the ethoxide, no? Yan. So, saan kakabit yung Br? Sa list substituted. Diyan yung Br. Saan kakabit yung ethoxide? Dito. Okay, so shortcut ko na lang, OET na lang. Meth et ethoxide, no? Okay. So, dun yung et ko, OET, ito yung Br. Then, finally, let's check kung yan ay may, if that's a stereocenter, yung dinudugtungan nilang carbon. Is this carbon a stereocenter? Yes. Say you have your methyl group, your ethyl group, then your CHBr. Magkakaibang group yon. Plus your OET, no? So, stereocenter yan, so we have to show wedge and dashes, no? Dito naman, is this a stereocenter? Yes po. So, yes ulit yan, no? You have your hydrogen here, your Br, the methyl group, and whatever is on the left side, no? So, yun. So, kapag ito ay wedge, what will happen to your OET? Your ethoxide, nakadash yan. That will push the methyl group forward, no? So, ganun lang. So, let's draw the molecule para malinis tignan. Ito lang. Okay, so draw natin yan. 1, 2, 3, 4. Yung BR, pupunta forward. Your OET, nasa likod siya. Then your methyl group will be pushed forward plus the enantiomer. Okay? Pwedeng yung OET naman yung nasa taas, yung BR nasa likod. Okay? Ganun lang. Let's have the next one. Ayan. Wala sir, ibang solvent yan. Ethylamine yan. Oo, ibang solvent yan. Pero, ganun pa rin yung process. No? Ang gagawin mo lang sa solvent kapag iba, bawasan mo lang ng isang hydrogen. Okay. So, ganun yung ginagawa natin eh. Ganun din gagawin dito. Okay? So, saan kakabit yung Br? Dito. Ito yung list substituted. Saan kakabit yung ETNH? Binawas ko ng isang hydrogen. Saan kakabit ito? Dito. So, dyan kakabit ang NHET. Okay? Yung nitrogen yung kakabit. Ito yung may lone pair eh. Okay? So, hindi yung hydrogen, hindi rin yung et ha. So, ganyan. So, kung sila may lone pair, siya yung mag-act as nucleophile. Keep in mind, sila yung mga Lewis bases eh. Yun lang. Ano na mangyayari? Wedge and dashes na. So, nakita naman natin, ito rin naman yung molecule kanina sa kabila. So, ipakita natin na wedge and dashes sila na. Okay? So, if yung Br nasa harap, ano mangyayari sa NHET? Mapupunta siya sa likod. NHET. Then your methyl group will be pushed forward plus the other enantiomer. Yung other enantiomer wherein this group is forward, ito naman ay nasa likod. Okay? So, yun lang. Ilang reactions ba tayo? Bilangin ko. Tatlong reactions na lang. Uy, malapit na matapos. Okay, so ganun lang ha. So, ano yung kailangan natin malaman ngayong araw? So, yung mga reactions na ginagawa natin, puro anti-addition, di ba? Starting from the halogenation. Okay, so yung halogenation, sila ay anti because of the formation of the bromonium ion, chlorinium ion. No? So, yan. So, nagiging anti-addition sila. Yung hydrohalogenation naman or halohydrin naman is ganun din, anti-addition. However, instead of the bromine or your chlorine attaching to that bromonium ion, instead na yun yung kakabit, yung water yung kakabit due to ano, due to the fact that your water outnumbers your halide, no? So mas mauna yung water kumabit. Then ayun, so reduce selectivity. Your bromide, your halide will attach to the least substituted carbon. Then your nucleophile will attach to the more substituted carbon. Okay, so ngayon naman, punta naman tayo sa anti-dihydroxylation and yung synhydroxylation. Okay? So, ano naman yung meron sa dihydroxylation? No? From the word itself, dihydro, dalawang OH. Okay? So, basically, what we're going to do here is that we will add two OHs sa ating alkene. No? So, for example, if you want your ethylene to be ethylene glycol, go it should undergo a dihydroxylation process. So, dalawang OH yung ibibigay natin sa kanya. Hindi pwedeng water kasi OH lang, hydration yung mangyayari. So, kapag dalawang OH yung ibibigay mo, tawag doon dihydroxylation. Okay? So, dalawang process yan, no? So, for example, the first process is that your alkene will react to this RCO3H. Ano yon? Peroxy acid yan. Okay? So, peroxy acid yan. Okay? So, yan, peroxy acid. So, it will react to your alkene to form this, what's called the epoxide. So, ano yung epoxide? That is a three-membered ring, no? Wherein yung isa doon ay oxygen. Pag makikita kayo ng triangle na may oxygen sa isa, epoxide tawag doon. Okay? Then what happens next is that your epoxide reacts with your acid, no? Kasi acid to. So magre-react siya with other acids, no? To form what's called the anti-dihydroxylation product, no? Or the trans-diol, no? So yan. Mapakita natin yung individual processes, no? So the first process is that your alkene will react to your peroxy acid. Ano yung itsura ng peroxy acid? Tatlong oxygen meron doon. Ayan, nagmumble-jumble na lang sila. So basically what happens here is that your oxygen, your alkene will attack this oxygen here, which is partially positive due to the fact na may dalawa kang oxygen na humihila ng electrons niyan. No? So maski kahit oxygen yan, hinihilahan pa rin siya ng electron. No? So as a result, this is prone to nucleophilic attack. So yan. So dahil sa induction effect, kung naalala nyo pa, aatakihin yan ng double bond. No? Then that closes the ring to form this epoxide. Okay? So ang itsura ng epoxide, that is a triangle wherein your bonds are on the same side, pwedeng nasa harap, pwedeng nasa likod, then oxygen yung isa doon. Okay? Plus your carboxylic acid product. Okay? So yan yung first step. Alkene plus peroxy acid, then you will have your epoxide and your remaining product na. Usually a carboxylic acid. So ano yung mga ginagamit nating peroxy acid here? So usually we use peroxyacetic acid, no? So that's an acetic acid with added oxygen, no? Or sometimes we use MCPBA or the methachloroperoxybenzoic acid. Ang daming pangalan, no? So meta yan because 1,3 position ng substituent sa benzene ring. We will discuss that in the future. So yung peroxy, ito yung chloro. Itong group na to ay yung benzoic. Okay? So yan. Ayun lang. So that's the first process. The second process is this one. No? Similar siya with bromonium ion. No? Yes. No? What happens here is that this is your epoxide. No? Ano mangyayari? Mapoprotonate muna yan. So as it becomes protonated, This will activate one of the carbons para kabitan ng water, no? So your epoxide under acidic conditions will be protonated as such as shown here. Then once na yung ating oxygen ay positively charged, that allows this carbon or that carbon na vulnerable na siya sa nucleophilic attack, no? Of course, ng water. Then ang mapapansin natin, ayun, mapuputol yung bond na yan. So you will have your OH here, then your H2O will attach here. Then finally, to regain the catalyst or to regain your acid, hihilahin ng isa pang water yung isang H. No? So you have your diol, anti-diol. Okay, so yun. So mapapansin mo, similar yung ating mga intermediates sa mga products, mga pinagagawa natin kanina. So we have here the epoxides. Ito ay for the dihydroxylation, the anti-dihydroxylation. This is the bromonium ion, which is nakita natin na useful in our halogenation and hydrohalogenation, or ang tawag doon? Hindi pala hydrohalogenation tawag doon. Halohydrin. Sorry. So halohydrin reactions. So ito yung ating mga intermediates, and this one, the mercurinium ion, which is an intermediate of the oxymercuration demercuration reaction. Okay? So lahat 'yan magfo-form ng anti-products. Okay, yun lang. Okay, so let's try to predict the products for each of the following reactions, no? So ano kaya magiging products dyan? So we have this alkene reacted with kalimutan yung pangalan. Basta yan, acetic peroxy acid, no? So you have your acetic peroxy acid, no, reacting with this alkene. So ang mangyari, may dalawang OH ka lang na ma-form. Yung isa nasa taas, yung isa nasa baba. So yan. Huwag na natin ipakita yung mechanism. Masyadong madugo. Okay? So yan, dalawang OH lang kakabit dyan. Yung isa nasa harap, yung isa nasa likod na. So if I choose this OH to be at the back, that will make this nasa harap as well as this one. Okay? So ganon. Ay, ba't ko nilagay sa harap? Sige, lagay ko na lang sa harap. Okay. Naduduling na ako. Okay, so ganun lang ha. So yan, pwedeng nasa baba yung isang OH, nasa harap yung isang OH, or nasa harap itong OH na ito, tapos nasa likod yung OH na yun. So ganun lang. So easy. Basta anti ha, anti-addition. Next one. Madali lang. Lagay mo muna kung saan kakabit yung OHs mo. Then, check if that is a stereo center. Is this stereo center? Yes. Kasi may hydrogen, may OH, may 3 carbon groups ka dito, tapos may isa doon. Okay? So this is a stereo center. So pwede itong nasa harap, pwedeng nasa likod. Okay? Let's check this carbon. Itong isa naman. Is this a stereo center? Ayun dito, maging stereo center ba yan? Pag kinabitan niya ng OH? Hindi. Bakit? Kasi may dalawang hydrogen sa carbon na yan. That will not be a stereo center, so wala tayong wedge and dashes for that. Straight line lang. Okay? So yan. Plus the enantiomer, of course. Ano yung enantiomer niyan? Itong bond na to nasa likod. Ayun lang. Ayan, alam niyo na yan. Okay, so sige, sagutan natin yung iba. Syempre, dalawang OH lang kakabit dyan. Yung isa nasa harap, yung isa nasa likod. Okay? So, draw natin yung product. Oopsie. Teka lang. Okay. So, ito yung isang product. Yung OH dito ay nasa taas. Ito ay nasa likod. Pwede rin naman ganito na OH yun nandito, nasa likod. Ito yung nasa harap. No? So, ganun. Ito, ganun din. No? So, yung isa nasa harap. Yung isa nasa likod. Okay? Ayan. So, ganun lang. Proceed naman tayo. So, if we have anti-dihydroxylation, we also have syn dihydroxylation. Ano kaya meron dito? Ay, imagine nyo, ipit na naman. So, imagine nyo may molecule na nakaipit, no? So, yan. So, paano yung syn dihydroxylation? So, usually you have your your compounds such as osmonium tetroxide, pwede rin naman permanganate ion, no? Okay? So, yung mga compounds na yun, ito yung lowest structure nila. So, mapapansin mo, your oxygens are on the same side, no? So, yan, nasa same side yung oxygens mo. So, kapag kumabit yan sa double bond, pag nag-clip yan sa double bond, nasa same side din yung oxygen. And that will result to syn dihydroxylation. Okay? So, anong difference niya with the anti-dihydroxylation? Your peroxides will form epoxides, which is an intermediate that will give you anti-product. Dito naman sa syn dihydroxylation, you have compounds such as this one, pwede rin permanganate, MnO4. Ganito din itsura ng MnO4, palitan mo lang yung nasa gitna ng manganese, no? Okay, so ano mangyayari dyan? Your oxygens are on the same side. So kakapit sila sa double bond on the same side. Then finally, you can remove that attachment with a reducing agent such as sodium sulfite or sodium bisulfite na. And so ano lang to? Kakabit muna on the same side, then finally i-reduce mo yan. So as it is reduced, matatanggal to. So you will have your OHS on the same side. Okay? Ano yung downside nito? This molecule OSO4 is expensive and toxic. No? So that's why sometimes we use other reagents, no? Such as NMO. No? Ayan, so yan daw itsura ng NMO. Okay, so yan. Although same lang din naman yan. Ito, sometimes we also use permanganate, gaya nga ng sabi ko. So, it can also be achieved with permanganate. So, saan siya nakukuha? So, pwede siya sa OSO4, pwede sa NMO, pwede rin sa MnO4, permanganate. However, it is only possible under mild conditions, no? Okay? So, mild conditions, ibig sabihin malamig, no? So, yan. Ayun, ganun din. Ayun. Ganun din mangyayari. So, your MnO4 will attach here on the same side, then you will reduce it to have your diol. Okay? You have this one. Ano mangyayari dyan? Same side yung OH, no? So, wag na natin pag-isipan. Ganito lang yung product. So, ayan. Nasa harap. Of course, plus the enantiomer. Okay? KMNO4, cold. No? Kapag KMNO4, cold, no? So, ibig sabihin, ito ay syn dihydroxylation din, no? Marunong pa ba ako mag-draw ng hexagon? Ayan. So, you have your OH here on the front. And another OH. Pero, hindi ko siya ilalagay as wedged and dashed. Bakit? Kasi this carbon is not a stereocenter. Okay? So, yan. Hindi siya wedged and dashed, no? So, line lang siya. So, hindi yan stereocenter. Always check kung stereocenter yung carbon. Okay? Let's have this one. Actually, paulit-ulit lang to, no? Ito, nasa harap yung OH. Ito, line lang din yung OH. Bakit? Bakit hindi siya dash? I mean hindi siya wedge kasi this carbon is not a stereocenter. May dalawang hydrogens diyan eh. Okay? Ayan, paulit-ulit na yan. Hindi ko natapusin yan. So, alam niyo na yung idea ha. Sin yung addition. However, if the carbon is not a stereocenter, you do not have to show it as wedge and dash. No? Okay, so plus enantiomer yan. Plus the enantiomer as well. Okay, so ganun lang. Next one, we have the oxidative cleavage. No? So, meron sa oxidative cleavage, mapuputol yung double bond. Ito favorite ko to kasi ang ginagawa ko dito para malaman mo yung product. Putulin mo lang yan. Tapos lagyan mo ng oxygen kada dulo. You have your two products. Diba? Ito yung pinaka-favorite reaction ko sa alkene kasi puputulin mo lang yung double bond. No? So, this is also called an ozonolysis process. No? Isa siyang reaction under oxidative cleavage. What happens here is that your double bonds are cut, no, to form this this carbonyl containing compounds, ketone and aldehydes. No? Okay, so yan. So this is one of the processes where you can achieve an oxidative cleavage product is ayun nga, you will use ozone. No? Okay, so yung ozone ikakat niya yung double bond, so you will have this carbonyl containing products, ketones and aldehydes. So ano nangyayari diyan? So this is your double bond, this is your this is your ozone, ito yung kanyang Lewis structure, then you will have your molozonide intermediate. So that molozonide intermediate will further rearrange forming your your carbonyl containing compounds, no. Okay? So ano yung special intermediate dito? Molozonide, no. So after the molozonide intermediate, magkakaroon ka ng ozonide intermediate, then magkakaroon ka ng reduction process, no. Okay, so medyo maraming nangyayari dito. Kaya ang ginagawa ko dito, pag nakakita ko niyan, instead na i-draw ko yun, pinuputol ko na lang yan. Mas maganda yan kapag naka-pencil kasi, magsasagot ka sa paper. During our time, dinodraw ko yung molecules, buburahin ko yung double bond, lalagyan ko ng oxygen. Tapos na. Kaysa naman i-draw mo yan, di ba? So, yung mga intermediates natin dito, molozonide, ozonide, no? Then, this will be turned into our products with mild reducing agents such as the following. Dimethyl sulfide, CH32S, and zinc in water. Let's predict the products of the following reaction. So, kapag ganito, lahat ng double bonds ay puputulin. Okay? So, lahat ng double bonds ay puputulin natin. Lalagyan yan lahat ng oxygen. So, ano yung mga pwede putulin? Ito. Pati ito. Ay, may video ko na naman. Diyos ko. Ay, naka. O nga pala, weekends ngayon. Okay. So, ayan, puputulin natin tong double bond na to and this double bond. Teka lang. Ay, Diyos ko. Hindi ko alam kung naririnig niyo yung tugtog sa paligid pero maingay. Okay. So, mangyari dito, you have your alkenes. Puputulin natin lahat yan. Tapos lalagyan natin ng oxygens yan sa kada dulo. Ito yung mahirap dito. Paano mo ipapakita yung mismong product, no? Okay. So, mapapansin mo, this part of the molecule will get detached. Matatanggal talaga siya dito sa group na to, no? So, one of the product is this one. Okay, so yan yung isang product. Kapag ito naputol, lalagyan mo lang yung double bond ng oxygen. Then, ano mangyayari dito? Madedetach ba to? No. Ang mangyayari dyan, continuous chain pa rin siya, no? ito. Yung mga carbons na yan ay connected pa rin. So, what we want to do here is, i-draw natin siya as a straight line. No? So, ilang carbon to? 1, 2, 3, 4, 5, 6. So, 6 na carbon. Hindi gawa ka ng backbone. Lagyan ko to ng carbon 1, 2, 3, 4, 5, then 6. So, on the carbon 1, I have my double bond. Lalagyan ko ng oxygen yan. On the carbon 3, I have my other double bond. 1, 2, 3. So, dito may double bond ulit. And sa carbon 6 sa dulo, may double bond ulit. Okay, so these are our products. Okay, so you have your aldehyde and ketones. Ano yung difference ng aldehyde and ketone? Sa aldehyde, you have your carbonyl, your C double bond O. Ang katabi niya ay hydrogen. May hydrogen yan dito pag walang nakalagay. Ang ketone ay may carbonyl ka, itong C double bond O, pero wala siyang katabing hydrogens. No? So those are the two products of our oxidative cleavage ng molecule na to. Naging dalawa siya. Ito, mapuputol yan. Acetone yan. And then you have this molecule. Ganun lang. Let's try some of the following. Ay, ang dami. Let's try the following. Ilan lang sasagutan ko dito, kaya na bahala mag-practice sa iba. Para masaya. Okay, putulin natin yung double bonds. Puro ano daw yan puro oxidative cleavage with ozone with dimethyl sulfide, no? Ano yung purpose ng dimethyl sulfide, DMS, to reduce, no? Yung ating ozonide intermediate, no? And sa putulin natin yan. Then ano yung mga products na magagawa natin? Ano mabubuo natin products dyan? Ito, draw ko yan. Okay. Then ito, naglalagay ko number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Carbon 1, may methyl group. Okay. Tapos may double bond O. Okay. So, ganun siya. Carbon 3, ganun din. 1, 2, 3. And sa carbon 6, may methyl group din. And double bond O. Okay. So, ito yung mga products natin. Okay. So, ganun ha. Hindi to aldehyde kasi may CH3 group ka doon. So, nilagay ko yun doon. Plus your double bond dito. Ito talaga yan. Sa dulo, ganun din, no? So, your methyl group. So, nilagay ko yung methyl group doon. Then, the double bond O. Okay. So, ganun lang. That's the oxidative cleavage. Okay. So, ganun yung oxidative cleavage siya. Try natin dito. Ito. Itong ring compound. Sige. Para exciting. Putulin natin yan. Ano magiging itsura ng product? So, pag ganyan yung case, kunwari yan yung problem, naka-ring pa rin tong molecule na to. However, ito, mapuputol yan, di ba? So, ano yung matitirang members ng ring? Itong carbon dito, 1, 2, 3, 4, 5. So, magkakaroon ka dyan ng cyclopentanol. Tapos, itong CH, itong group na to, ganun siya. Okay? Ayan yung itsura niya. Parang si SpongeBob siya na galit, no? So, yan. So, ganun magiging itsura. Putulin mo lang yan. Tapos, lagay mo sila sa gilid. Lagay mo sila dito sa magkabilang gilid. Okay? So, ganun. Sana na-imagine nyo, no? Ayan, 1, 2, 3, 4, 5. Ito yun. 1, 2, 3, 4, 5. Then, since pinutol mo yan, yung isa mapupunta sa left, yung isa mapupunta sa right. Ayan. So, ayan yung ating product na oxidative cleavage. Ito pa yung isang trick dito. From your product, haalamin mo yung starting alkene niya. Kunwari, ito. Ito muna tayo. So from this, alamin natin yung original alkene natin. So basically, ang mangyayari lang doon, burahin mo lang yung oxygens. Tapos pagdugtungin mo yung dalawang line na yan. No? Kasi mahirap dyan yung pag-drawing uli. Okay. So paano ko ito i-draw? So you have your double bond, idudugtong mo yun doon. Ilang carbons yan? 1, 2, 3, 4, 5. 5. Tapos may double bond doon sa 1 and 5. No? So parang siyang para siyang cyclopentane. Tapos may double bond doon. Okay? Then, at each end ng double bond ito may CH3. Tapos ito naman sa kabila may CH2, CH3. CH2, CH3. Ay, ang pangit ng drawing ko. Teka lang, ayusin ko. Pero ganun yung gagawin nyo kapag ganyan yung problem, ha? So, basically, what you're going to do is pagdugtungin mo lang yung double bonds, no? Bilangin mo kung ilang carbon. 1, 2, 3, 4, 5. So, cyclohexane yan. Ay, naku, ngayon pa sila nag-video. Okay. Kasi yan, nandito yung double bond, yung CH3, then yan. Okay, so yan yung ating starting reagent na. Pag pinutol mo yan, magiging ganito yung itsura niyan. How about this one, itong number 2. Kapag dugtungin mo yan, 1, 2, 3. Ano yan? Triangle lang yan na may double bond, no? Tapos, may kanya-kanyang methyl group doon. Okay? So, yan yung itsura ng reactant dito. Draw ko na maayos dito sa gilid. Triangle, may double bond, then may dalawang CH3. Okay, pag pinutol mo yan, ito yung may itsura niyan. Ito yung C, ayun. Ito, magkakaroon ng C double bond O. Ito yung carbon dito. Tapos another C double bond O, then another carbon. Okay, so, imaginative na lang yung ating gagawin dyan. Imaginative dapat. Last one. Paano kaya to? C10H16. Tapos yan yung product. Piling ko may kulang dito. May kulang dito sa molecule na to. Pag nilagay kasi yung CO2, okay, so piling ko kulang to ng isang check ko lang. May nakalimutan pala dito sa sa screenshot ko. According sa textbook, hindi pala CO2 yung kulang diyan sa screenshot ko. Ang kulang ay ganito. Teka lang. Sabi ng libro natin, 2 equivalents daw to. So, ano meaning ng 2 equivalents? Dalawang ganyan, no? Okay, so that means kung may dalawa tayong ganito, sila yung original na magkadugtong. Kasi kapag inozonalysis mo yun, magiging separated talaga sila, no? So, yun na naputol sa screenshot. Okay, so yun. So, you have 2 equivalents neto. So, ibig sabihin, originally, itong dalawang bond, double bond, magkasama yan, no? So, ano kaya itsura ng reactant na yan? You have this stuff. Ayan. So, ito yung itsura ng ating reactant dyan, no? So, kapag pinutol mo yan, pag in-undergo mo yan ng ozonolysis, ito yung magiging product natin. Okay? So, basically, pag dugtungin mo lang talaga yung double bonds, no? Yun. Yan lang. Yan lang. Okay. So, ito, summative, ano na lang to, summative part, no? We can do this, pwede rin hindi na lang, no? Pero, dadaanan na lang natin to real quick, no? Para matapos na tayo. So, basically, the summary of our lesson, when we are predicting the addition products, kailangan alam mo kung saan kakabit yung nucleophile, alam mo kung regioselective siya, if that's Markovnikov and anti-Markovnikov, at saka alam mo rin dapat kung syn and anti-addition yung magagawa mo. Okay? So, ganun lang yung pinaka, niyan, pinaka key idea, no? So, kailangan familiar kayo kung ano yung mga reagents na, oopsie. Okay, so kailangan alam nyo kung anong reagents yung mga magkukos ng Markovnikov product, anti-Markovnikov product, kung syn and anti-addition yung magagawa natin, no? So, dito sa last slide ng ating lesson, naglagay ako nito, no? So, ito yung pinaka-summary ng reactions natin with alkenes, no? For example, this is, ito, pag naging ganito siya, that's ozonolysis. Ito ay, syn addition ng syn dihydroxylation yan. Ito din, with KMNO4. This is anti dihydroxylation with your peroxy acid. This is halohydrin reaction. This is halogenation reaction. This is catalytic hydrogenation. Basically, maglalagay ka lang ng hydrogen dyan. This one is the nang buo dito? Anti-Markovnikov product, no? Kasi yung OH, di siya nakabit sa more substituted carbon, no? Ibig sabihin, dito siya sa least substituted carbon kumabit yung nucleophile mo. So, this is, since may BH3 yan, that's Hydroboration Oxidation. Ito naman, so this is Markovnikov product, yung OH kumabit sa more substituted carbon compared to this one. Okay? So, this is mercuration demercuration, no? Oxidation demercuration process. Pwede rin yan through acid catalyzed hydration. Okay? So, kailangan familiar talaga tayo sa mga ganun na. Okay? So, this one is the acid halide, no? And yun. Okay, so yun lang. Ito yung unang lesson natin. Ito yung acid halide. Tapos ito yung kapag may peroxide, no? Di ba sabi ng pag peroxide naging anti-Markovnikov siya. Okay. So yun lang. So yan yung ating mga summary yan yung summary ng ating reactions. Basically, pwede yan na lang yung kabesaduhin mo. No? So andyan naman yung markers. Okay? So ako, ginagawa ko kasi nung nagre-review ako ng board exam, ito yung tinitignan ko lang. Kumbaga, may libro kasi ako nitong ni Klein. Yung dulo agad yung binabasa ko. Okay. Tapos kapag may question ako, doon na lang ako maghahanap sa first part ng libro, sa mismong discussion part. Okay? So, yun lang. And also, kailangan imaginative din tayo sa ating mga magiging reagents. Ha? So, yun lang. Such as yung ginawa natin dito sa ito. Kailangan ma-imagine nyo kung ano kayang original itsura nila before siya maputol. Okay? Anong part to? Summary na lang to. Kahit di na natin i-cover to, okay na yan, no? Basically, yan yung pinag-add na lesson lang ng alkyl halide and etong alkenes topic na. Okay? So, sana naalala nyo pa yung Marconic, yung tawag doon, yung Zaitsev and the Hoffman product, no? So, depending on your, ito, balik ulit tayo sa alkyl halide, no? So, depending on your base, you can either have a Zaitsev and Hoffman product. If your base is bulky, such as tert butoxide, yung TBUOK, okay, so hindi niya ma-access itong hydrogen dito. So rather, it will access the hydrogen at the terminal. So you will have your terminal alkene, that's the Hoffman product. Pag yung base naman ay maliit lang, such as methoxide, OME, So, pwede niya ma-access yung hydrogen dito, forming the Zaitsev product. Okay? So, yun lang. Kahit di na natin i-cover yan. No? So, basically, yan na rin naman yung mga na-discuss last time. No? Okay, so with that, we're done. Tapos din. So, tapos na tayo sa lesson natin na tawag dito sa subject na to. Tapos na tayo sa lesson ng ating addition reactions ng alkenes. Alkenes, yes. No? Okay, so sa next meeting, ano yung lesson na ba tayo next meeting? By the way, feeling ko may nakalimutan kasi ako ilagay dito sa ating reactions eh. May onting adjustments akong gagawin dito sa ating pakita ko lang yung canvas natin. Close ko muna. Tapos na tayo sa PowerPoint eh. So, may onting lang ako dito gagawin. Onting adjustment sa topics natin. Kasi may nakalimutan pala ako ilagay. Kasi, after the alkenes, alkyne, no? So, alkyne tayo next week. Pero, after ng alkyne, mayroon pa palang isang topic. Yung radical reactions. Kasi hindi natin na-discuss yung reaction ng alkane, di ba? Merong reaction yung alkanes, no? Radical reaction yun. So basically, mauurong lang ito. Itong chapter 10, mau-adjust yan, no? Pero, ano mangyayari? May isang hindi na tayo i-discuss dito. Siguro ang topic na hindi ko na i-discuss ay itong ethers, epoxides, thiols, and sulfides, no? Kasi hindi naman to masyadong, hindi naman to common eh, no? So, ito lang kasi mga common natin, alkane, alkyl, alkyne, alkyl halide, alcohol phenols, aromatics, aldehyde, ketone, carboxylic, and amines. So, I'm gonna switch itong ethers, epoxide, thiols, and sulfides, no, with, ang tawag doon? With radical reactions, no. So, yun yung nakalimutan ko i-type dati. Okay lang naman na-skip natin to kasi trivial na rin naman to, no. Ethers and epoxides, they function as alcohols din naman, no. Parang alcohol din sila. Okay, so yun. Yun lang. So, skip na natin tong part na to. Basically, parang alcohol lang din yung reactions dyan eh. Okay. So, yun lang. By the way, yung case-based learning project ninyo, no, yung chemicals ay hindi pa rin nasi-shape. Okay. Pero yung isang case-based learning project nyo, gagawin ko na lang tong paper, no. Parang essay lang, no. Although, syempre may rubrics yan. Bibigay ko na lang yung rubrics siguro next month na lang. Okay? So, next month for sure, madadeploy ko na sa inyong mga bahay yung chemicals na. Okay, so yun lang. Yun lang. So, yun na. After alkynes, we will have your radical reactions. Pagpapalitin ko to na may radical reaction na lang yan. Then, yan. Ano pa yung kailangan ko i-sabihin? Calendar natin. Punta tayo sa calendar. Ilang topics pa meron tayo? 1, 2, 3, 4, 5, 6, 7. 7 topics pa meron na. Okay, so tingin tayo sa calendar natin. Ang aking worry lang kasi, itong part ng year, itong November, December, October, November, December, may mga holidays, no? Asan na tayo? Ito. Magpapasko na. Okay. Sa ibang university, nag-suspend sila ng klase starting 28 until November 2. UST ganon, Mapua ganon din. University of the Philippines, ito naman yung walang pasok nila. So, I don't know for FEU, no? Pero nababasa ko yung mga tweet ng mga bata. Sana naman. Sana all. Okay. So, tingnan natin kung may suspension si FEU sa part ng week na to in observance of the holiday or wala. Okay. So, ganun lang. So, we still have 7 topics to go. Okay. So, natapos natin yung alky. So, next week, alkynes. Though, hindi pa natin sure kung meron tayo dito sa latter part. No? Okay. Pero if ever ganun, i-record ko na lang sarili ko. No? So, alkynes. Then we will have the radical reactions, alcohol and phenols. Tapos ano yun? Ano yung kasunod nun? Alcohol and, ayan, saan ako? Your alkynes, radical reaction, alcohol and phenols, tapos aromatic compounds, aldehyde and ketones, carboxylic acid derivatives, and finally, amines, final exam. Okay? May birthday yung kaklase ko. Okay? So, hanggang dito lang tayo. Then, yan. Dito banda, dito na tayo pwede mag-consultation kung ano yung final grade nyo. No? So far, so good naman. Mataas naman standing nyo sa akin. No? Tataas ng grades nyo rin naman kasi. No? So, yun lang. As usual, every week may chapter talaga tayong i-discuss no before the exam. So just in case lang na may may class suspension, magre-record na lang ako ng video na pwede niyo panoorin no. Total yung ating assessment naman ay by batches no. So hindi naman agad required na panoorin niyo yung video agad-agad no. Kasi yung ating assessment, yun nga, sama-sama naman yung topics doon. So, pwede skip nyo muna. Next week nyo na lang aralin, no? Yan. So, ganun lang. Yun lang naman yung concern ko. Okay. So, with that, tapos na po yung lesson natin. No? So, I'll see you again next week. Our topic will be on alkynes. No? Okay. Do you have any questions po ba or okay na tayo? Okay na naman. Sige. Basta yan na. So, I'll see you next time na lang. Then, again, yung case-based learning project, yung chemicals, ako na magpapadala sa inyo. Tapos, ano pa? Yung, criteria for your, another case-based learning project, which is just a paper. Hindi naman kailangan super haba na paper, no? So, may papabasa lang ako sa inyong articles, mga journal publications, no? Na yan, pwede nyo kunan ng ideas, no? Of course, related sa pandemic natin ngayon, no? So, i-relate ko naman lahat sa mga nangyayari sa paligid. Okay, so, yan, isip kayo ng kayo pwede ibigay ni sir na topic for the COVID-19 pandemic, anong papers kaya, no? So, lang, madali lang naman, no? So, gagawa nyo lang siya ng, pinagsama-samang concepts, yan. Don't worry, mataas naman ako magbigay ng grade kapag essay, no? Kaya yan. So, yan lang. So, I'll see you again next week and enjoy the weekend. Bye-bye. And upload ko to sa YouTube ha. So, ingat. Bye-bye.
Thank you, sir.
Okay, kain na po.